Okay, hi everyone. Welcome to tonight's meetup on React testing. Justin, I'm with Mike and Thor. Sorry, I'll pronounce your name terribly. Xola. uh, and yeah, I just want to quickly I will just do a quick thank you to sponsors, etc. And then Mike will take over to do the introductions, and then we'll get into the talk. Please post any questions that you might have in the YouTube chat, and we will answer them at the end of the talk. Right. So, yeah, welcome to another PETSA meetup. Thanks for joining us. We just want to thank our recurring sponsors. That's nml.co.za, who've been our sponsor for 10 years, and IO is both software development companies in Cape Town who give us a lot of support and allow us to bring you these events. And then we have a specific sponsor for the React Africa series, and that's Vulcan Labs. You can check them out on vulcanlabs.com. And then finally, just one more meetup happening in October, and we're having another hackathon weekend. That's happening on the 24th of October, and you can check that out on the meetup group if you're keen on attending. Okay, I'm going to hand over to Mike to do the introductions, and then we'll get into.
Awesome, super. Thanks so much, Justin. Xola, we're going to go with that. I'm not going to make the gracious attempt that Justin did. I'm so glad that you are joining us to share your knowledge in this space. It's really exciting. I think this is something that's been developing quite rapidly. So I think a talk on this topic is going to be really, really valuable. For those that don't know, Xola is a lead software engineer at International Frontends, and he's working at ClearScore. He's got a wealth of experience, and we're very happy to have him sharing that with us tonight. Xola, when you're ready, please feel free to take us away.
Cool. Hi, everyone. Yeah, as Mike and Justin have said, my name is Xola dos Santos, and I'm currently building a career as a lead software engineer for international frontends at ClearScore, which means I'm deploying screens that are used by an active user base, the active ClearScore user base of over 17 million users across London, Canada, South Africa, and Australia. And I've actually been programming in JavaScript since high school. I started in 2009. And since then, I've kind of like worked in a few corporates in the education sector, in the gaming sector, and in the finance sector over the last 10 years. So today I want to really just discuss software testing and the software testing process as it relates to my most recent experience as a front-end engineer. So my focus will be really on how to think about testing. So a few testing paradigms and the different types of tests relevant for front-end engineers, mainly automatic testing. So we'll speak briefly around release testing and user testing as well. But my focus really will be on development testing. Now, there's a whole lot of concepts that I just spoke around now. I will try and distinguish between these, all of these different types of testing in later slides. So the most important question to ask when we talk about testing is, what are we trying to achieve by testing? And for any of you who have studied project management, you might be familiar with the Project Management Institute or the Project Management Book of Knowledge. So we want to use the best practice approach for testing, right? And according to the Project Management Book of Knowledge guide, which has been adopted by the Institute of Electronic Engineers, the current best practice approach for general testing strategies is the double V model, right? And this can kind of be described as a intermediate development model that sits between the more waterfall model and agile development, with more emphasis on testing at earlier stages in the waterfall. So we know we need a very rigorous development lifecycle model, and the V model is designed with these types of needs in mind, right? So the V model as it's applied, kind of can be categorized into three broad categories. There's the German V model, and then there's the general testing model, and then there's the US government standard. All of these are broken up into two phases: validation and verification. I'll be focusing more on the general testing model, right? So the general testing model can be broken down into two sections. There's the validation section or tests, and then there's verification section or tests. When we talk about validation, what we really are asking is, are we even building the right product, right? And if you look, I'm just gonna annotate on this. So validation sits above this line here. And the question here really is, are we even building the right product? From a commercial perspective, we have to have assurance that any product that we are building or any service that we are building or that we intend to build meets a specific customer need. And there are also various models and tests that go along with this, right? From user requirements models to when the product, the live code is in production, doing things like user acceptance testing and having test cases and test suites that speak to the match between what we've developed and how it solves the user's needs. But for this talk, we're more focusing on verification, which is concerned with whether we're building the product right? And from an engineering perspective, we need to really just evaluate whether or not the front-end systems, in this case, that we're building complies with any sort of technical specifications, right? So verification testing takes place during the development and release process, sorry. So again, just continuing on, why do we need testing? Testing just makes economic sense, right? We should try and have tests happen as soon as possible in the software development cycle and as often as possible. And we have this graph here that kind of explains the cost of a bug, right? If we squash a bug during the development phase, it doesn't really cost you anything apart from the labor hours involved. But if you go, obviously, if a bug makes it past staging and into production, not only will it cost you in terms of your reputation, but you might also lose confidence from customers as well. So when a software company brings a system into the market, it must take into account competing products and the schedule for delivering that specific piece of software. And because we live in such a competitive environment for software, a company might, for instance, decide to release a piece of software before that piece of software has been fully tested and debugged, because it wants to be first in the market, right? If this product is free, or if it's just a prototype of a game, users might be willing to tolerate lower levels of reliability, right? They might be able to tolerate a few bugs. However, as the company grows or your software product becomes more established, you should have a testing strategy in place, because users will expect your software to become more reliable, right? Which is why you need a testing strategy. Consequently, more thorough testing or later versions of the app will be required. So you might want to incrementally improve test coverage over time, right? So let's zoom into we're gonna kind of ignore the validation phases of the V model as a testing strategy. But most of the stuff that I've gotten from actually comes from, most of the resources I've gotten from comes from a wonderful textbook on software engineering by Ian Somerville called the Software Engineering 10E textbook, as well as testingjavascript.com has also some amazing resources. But so typically for commercial software, there are three categories of testing during the verification process, right? There's development testing, which is what we'll be focusing on, where the system is kind of like tested during the development phase to kind of find bugs and defects, right? So here we're talking about system designers and developers and programmers are involved as much as they can be during the development process and their testing, right? Now, development testing has a few categories of testing within it, right? We have unit testing, component testing, end-to-end testing, and static tests, right? To touch on these very briefly, unit tests are where you're specifically testing an individual object or a class. So a unit test will look at an individual object or class and look at its properties and try test the properties and the methods of a specific unit or class or object. Whereas component testing is where you combine where several units are integrated and tested to create composite components. And component testing should really focus on testing the component interfaces that provide access to other components, right? Then we talk about end-to-end testing, where some or all of the components in the whole system are integrated and they are system tests that are run across the system as a whole. So system testing should really focus on testing how components are interacting with each other in a system. And a really good tool, which I'll be demoing later, that helps us do this is Cypress. And for web developers, especially React web developers who use Cypress, Cypress basically uses a helper robot that kind of behaves like a user logging into an app to click around the app and verify that everything works properly. And then the last category of tests are static tests, which are just tests that catch typos in your source code and catch type errors as well as you're actually writing the code. So the second major category of testing that takes place during the software development lifecycle is release testing and post-release monitoring, right? And again, given that we are operating in such a fast-changing environment, it's important that after we release our code into the public, into the wild, we continuously monitor and review each change. So how do we do this? Obviously, we can't manually monitor these things. We need to set up alerts. And if we find that our original features don't have the desired effects on users, we can then change our strategy, right? So if our alerts are telling us, since you released that login page, users are no longer logging into the app, we then obviously need to change our strategy. We need to revert the code or do more feature development. And there's a lot of tools in the marketplace that can help you with this. Of course, working at ClearScore, we have our tech radar out in the public, and we're using signal effects to do post-release monitoring, Sentry, Domo, Amplitude, amongst other tools. And then the last category of testing, which I won't really talk around, is user acceptance testing, where users are testing the actual system in their own environments. And this, if you remember the V model for test strategy, this would happen at the end of a typical waterfront software lifecycle or an agile, or at the end of the sprint for in an agile lifecycle, right? And when user acceptance testing happens, we're basically having the user formally test the system to decide if the system should be accepted into the marketplace, right? And just to briefly touch on different types of user tests, of course, we have alpha testing, beta testing, and acceptance testing. Alpha testing would be where you have users from the real world who are closely involved during the development lifecycle, who are working closely with your developers to test your users. So these are your early adopters type users. Then beta testing is where you actually release your software to a population segment or a larger group and allow them to kind of experiment and raise problems that they discover with your software, right? And obviously, acceptance testing is just something that happens at the end of the software development lifecycle, where users are the main users who are majority stakeholders will decide on whether we should continue with the software project or not, based on the performance of the software. So it might be difficult to focus. I mean, there's so many different areas to test and test coverage. And now that we know that when we talk about testing, we're not just talking about unit or integration tests, but also user acceptance tests and stress testing models before the and requirements modeling tests before software development even begins. So then how can we focus our thinking around testing, right? The most popular sort of model for really deciding what to test during development testing is the input-output model of testing. And this figure kind of illustrates what that is, right? And shows the difference between validation and defect testing, right? So think of the system that you are developing, whether it's an app or a service, as it being kind of a black box, right? And this system kind of accepts inputs from some inputs and generates some type of output, right? So some of the outputs will be erroneous, and this means the system isn't entirely free of defects, right? So the existence of erroneous outputs demonstrates that our system can't be entirely free of defects, right? That it will behave unpredictably given a set of erroneous inputs. So when we're coding, we need to focus on that set of erroneous inputs and try to code defensively, really, in order to prevent undesirable system behavior. So the priority in test-driven development, or in most test strategies, is identifying which set, within all inputs, will produce those undesirable behaviors, right? So now, enough with the theory. Let's talk about React and practical ways that we can test and libraries that are out there to allow us to test, right? So let's talk about the React testing library, and this is really a library that provides various utilities that allow us to query the DOM and manipulate the DOM in the same way that a user would in a browser window, right? So it'll be finding elements in the browser window using things like labeled text, just like a user would. So finding links and finding buttons, and it can also find elements on the DOM using test IDs or QA IDs, but this is not the most recommended approach. Really, this library, in finding DOM elements the same way that a user would, by traversing the DOM and looking for bits and pieces of text or buttons or component types, the library encourages your application to be more accessible and gives you more confidence that your application will work when a real user is actually using your app, right? So you don't want tests failing because of implementation details. You want to write tests that manipulate your app the way a user does, without having too much concern around how functions are being called and their internal logic. And React testing library kind of encourages this thinking. You might be, so React testing library is a replacement for another library that has been quite popular over the last few years, called Enzyme. And its main features are that, again, that it queries and returns DOM nodes during a test run, and it provides APIs for querying those DOM elements and for waiting those DOM elements to appear and disappear off the window without you having to forcibly like re-render the actual window. And really, again, just to emphasize this, the API kind of focuses on interacting with elements and the UI in the same way that a user would. It does support React 17, which Enzyme doesn't. So if you are going to be putting together a testing strategy, rather use React Test Library and Cypress, which I'll speak about later. And I was looking at some charts as well. I was going to include them here, but it is very well supported and has more monthly downloads than Enzyme. So a few sort of key concepts in React Test Library. So an automated React Test Library test can be split into 3 parts. We have the setup part, and then we have what's called a call, and then we have an assertion, right? And I'll go through these in detail in a second. So in the setup part, we kind of initialize the system with the test case. So remember earlier on, I spoke about the input-output model. So before you run tests on your components or the units or the system that you're testing, the test suite should include all of the necessary inputs. Not only the inputs that will confirm that the system behaves as expected, but also inputs that might make the system behave in unexpected ways. And then the challenge really, looking at those tests for an engineer, is to be defensive, right? To prevent the system breaking down because of the erroneous inputs. So in the setup step of when you're writing a test, you are initializing the system with the correct inputs. And you see here in this example here, this is a test that a Cypress test that would be looking at my website, because it might be the test suite might go through every single page on my website. There is a similar step before each test. So we might have 4 tests, a test to go to the about page, to the contact me page. But all of those tests kind of start with visiting the site itself, right? So this would form part of the setup. If we were testing an application, the first sort of setup would be making all of the services, all of the API services that the test might need available. So this is what we mean by initializing the system. And then the second step is then the call step, right? So after we initialize the system, we do a call, right? We find the elements within the system that need to be tested. We identify them within the system, right? And React Test Library has a few utilities and APIs available to us that allow us to do this, to query the DOM. And you see that I have a little bit of an example here, right? We have the submit button. We're finding a submit button using this query where we're looking for a button that has the name prop set to submit. So we're using get by role for the query in this specific scenario. But if, let's say, we had a screen that had many buttons or many lists or many forms, we could use get all by, and where an array of all of the buttons or forms or list items would be returned. So we have a few, or we also have get by and find by. So we have a few available APIs that help us query the DOM and improve the core phase of our test, right? And I've included some examples here as well for specific usages of these various queries. So then after we have found the actual element on the page, we might have to manipulate it some way in order to before we actually do the assertion. So we can call the object or method that we want to be in RTL, and then do something on it. So if it's an input, we might want to type into the input, or if it's a drop down, we might want to drop down to the third element in the drop down. And within React Test Library, and I'll show some examples in a bit, we have available to us the user event object, which is built on top of Fire Event, but kind of more closely resembles how a user might interact with a component. So you have all of the Fire events, all of the events, JavaScript events that are being fired when you're using user events, right? Again, like if you're typing, you might want to also test that there's a side effect that happens when you are pressing the key down or pressing the key up, etc. So user event gives you that sort of power. And then the last sort of step in a normal test is the assertion, right? And really here, this is the final step in a test case. And really here we are comparing the result of the call with an expected result. So if the assertion evaluates to true, the test has been successful. If false, then it has failed. I'll show you an example now. So obviously, these objects that we are testing don't always exist in isolation. Sometimes so we might want to test, and it might not make sense to test a button on its own. We might want to test a submit button in the context of a form, right? So sometimes the objects that we are testing have dependencies on other objects that may not be implemented, or we might want to test a form, for instance, but during the actual test run, for efficiency reasons, we don't want the test running, making an actual API call, right? The backend might not actually be available to deliver actual data. And even if it is, you likely don't want your tests depending on the existence of servers that are up and running. So yeah, again, in this example, in an example where you have a call being made to a database or any sort of network layer related actions, and those services might not be able to deliver data, then you would use what's called, this is when you would use what's called a mock service worker, right? And a mock service worker kind of mocks out, runs a fake server, right? So mock service workers work in Node only, and you can mock out not only like REST responses from services or backend, but also GraphQL responses. And recently, there's been a Storybook add-in that's been added. I don't know if any of you know about Storybook, but you can actually write stories for your components that use query or use context and even Redux that have services being mocked up in the Storybook test. And mock service workers also work in the browser for like Cypress tests. So you can see the fake request being made in your network tab if you are familiar with the browser dev tools. And again, mock service workers work with Cypress as well as RTL. So I just want to show you guys some examples now. Enough of the theory, and then I'll open the floor up to questions. So here's an example of a a very basic application that makes an API call. I'm just gonna close node modules. Here's a very basic example of an application that's using React query to cache responses from a backend. It's using a hook to fetch some data, and then that data is listed on a page. I'm just gonna run this yarn.
Sorry, Xola, we still only seeing your slides.
Oh, sorry about that.
There we go. Great. Thanks.
Sorry, I got too many computers open here. All right, cool. So I'm gonna run this very basic app. Yarn start. Should open up a window in a second.
Sorry, me again. Can you just zoom in a bit? Or full screen it.
Oh, okay.
It's a bit small. Thanks.
Cool. Not a problem. Cool. So the API, the service in this instance just returns the string query, but we can see that there's a network request being made. And the network request is returning all of this GitHub data, right? From this, all the public GitHub data from this user. And then returning the name node on that data JSON, which is query at this point in time, right? So now, how do we test that? You'll see we have two tests, right? So we have test that confirms that the API service call works as it should, right? So here's the if any of you know and understand, most of you should understand mutations. We are waiting for the API call to resolve, and for the is success object literal, the is success key on the object literal to be true, and then within the data that's being mocked within our test, we expect the data.name to be mock React query. So again, here we're not using actual data here. There's a little bit of a setup that we're doing right over here, and then we are then making an assertion. So this is setup, and then this is the call, and then this is the assertion here. And then we also have a test with erroneous data, right? So here we are, instead of the call being made again directly to the GitHub API, we are intersecting that API call and returning a 500 response. So this is setup here, and then we are doing the call here. So we are waiting for, we are loading, this API call runs when the component is mounted, and then we are waiting for is error to be true. So this is a use query function, and then we are doing an assertion here that there is an error object and that it is defined. Cool. So now let's briefly talk about Cypress tests in a second. So a convention when dealing with tests is to name your files like .test, to include .test or .specification in the name of your files. So these are RTL tests that are running in a headless browser, right? So now let's look at so this would be good for unit or an integration test. We might want to then test the whole system. We can do this with RTL as well, but it's a little bit cumbersome. We have available to us Cypress for this use case. So let me just open up an example here. So these are the examples that come with a basic Cypress installation. But I want to show you some of the tools available to us on Cypress, right? You might recognize the window that will pop up. It's a Cypress. The Cypress tool is built using Electron, very much like Visual Studio Code. And the UI tool, which I'll show you in a second, basically lists all of the tests within the specific repo and allows us to either run them all at the same time or run them one after the other. So I'm going to open up a simple test for a to-do. Sorry, this window is opening on another window. Just give me a second. Okay, it might be a little slow. Just a second. Cool. So here are the tests here. Here's the test suite here. So we have a few tests that are listed here, and we can see for our example to do app, the first sort of setup is going to example.cypress.todo, and these are the individual test cases, right? So we test that we query the DOM and find these two to-do items. So you see if I press the DOM, we have our setup here. And then we're querying for these for two list items, and then we are using using Cypress in the scenario to actually type to add a new to-do, right? To test that we can add a new to-do item, and then we also want to be able to check off a new to-do item, and Cypress allows us to perform those key press events. Cool. So that's all we have time for today. Are there any questions?
Hey, Zola, thank you so much for your presentation. I have a question that I'd like to ask you. In the landscape of dev in South Africa, there's always a focus on delivering features and business value. How do you advocate for testing and ensure that it's something that is prioritized by business? It's a problem that I always run into. You know, like every developer values testing because you'd rather have a test fail than have something in production fail, as you explained earlier. But how do you best convince business that this is really where the value lies?
I think the best strategy is to, I mean, if you have really smart people, and some of the people that I come across who work in tech are some of the brightest people that I've met, point them towards best practice. Again, I want to emphasize that the project management book of knowledge advocates the double V or the V model for testing. It's also been endorsed by the Institute for Electronic Engineers. And speak to recent failures as well. So I didn't really speak around this during my talk, but in South Africa we've had recent failures, like huge failures, system failures. I don't know if you guys remember, we saw a major failure in August where Capitec Bank, which has a customer base of over 16 million people, was experiencing major infrastructure problems with its central servers. And there was a whole, Twitter went crazy as users were not able to do any internet banking or even use SSD services. Then earlier on this year as well, the Standard Bank head of IT engineering, Alpheus Mangale, resigned after, again, at Standard Bank, there were a series of system failures. Servers are falling over, UIs were broken, etc. So there is definitely, and when these things happen, they're massively embarrassing for a business, and you might lose customer or at least customer confidence. If you're a small startup, you might get away with not testing just to get your product to the market. So I would just point, but if you're an established business and you as an engineer, if you're in an established business and you as an engineer need to really make a case for testing or test-driven development, then I don't think that business is going to be around for much, because you need, as engineers, we also need that psychological safety, knowing that code that we touched like 6 months ago won't cause everything to break with a new feature. So like in terms of mental hygiene, just for us as system engineers, having tests and having that confidence that we have test coverage, and when the intern comes in, they're not going to bring down production, because we'll catch the errors before we bring down production.
Sorry, Zola, all I can think about is the discovery notification that went out probably about a year ago at this point. I'm not sure if you guys remember a test.
Yeah.
Like, I don't know how many million people saw that, but it was astronomical.
Yeah.
It's always
And
such a tough
Airbnb
one,
as
you
well.
know? Oh, yeah. Damn.
And Airbnb.
Yeah, Airbnb also did a test.
I mean,
tens of millions of people.
Testing is really important, but I'm not sure if it's that important.
Yeah, but also, it's not something that should just happen haphazardly. The business has to have a testing strategy. So there needs to be a commitment from the top that, we need to increase the amount of releases that are going out. They all need to be like a production quality code, and they have to have test coverage. And this is very tricky, because a lot of the time, I hear you, Mike, people just don't care about tests. It's like it's an afterthought.
Yeah, and I mean, in fintech, it makes complete sense. Trustworthiness is critical for anyone in the fintech space. I worked in the gaming industry, and I worked on a system that was seen by millions of people, and we had no testing in place. And that idea of the psychological safety blanket of there being, some sort of security that a change that you make isn't going to break something that someone else touched 6 months ago. That's something that's so important. It really it wasn't conducive to working in a healthy way. It sucks to be anxious when you submit your PRs. Like, is something going to break? And in my case,
I think in gaming, especially because I also worked in gaming for about a year and a half. there is not so much of a drive for testing because the focus is more like on animation and motion graphics and sound. But definitely in fintech, we're dealing with people's money. Like there's a huge. In fact, I sometimes spend a week just writing tests and justifying my tests, even if it's a relatively small change.
Yeah.
So again, it depends on the industry, I suppose.
For sure.
Can I ask a question around how you structure your test writing work within like a sprint? Do you we all do these things called estimations, whatever that means. When you have a story, for example, and you do an estimate on that, would your estimate include writing tests?
Your estimate should include writing tests, but again, testing doesn't start when in the development phase. Again, so when your product managers come to you with the new feature requests, they have some idea of how it's intended to be used and how it could be abused. So they should also come with a requirements model or a data model that you can then build on for your tests. So they should actually be, if you're working with good product managers and analysts and strategists, they would hope that you would actually block out time for tests. Like it's not something that we do for fun as engineers. It's actually a part of the whole software development life cycle.
Yeah, the life cycle. Yeah, absolutely. But as you say, it is a hard sell, and as Mike mentioned, you have to make that argument that the work that we do now is going to save so much effort later. And you need to.
Has anyone here ever been taken down production this year?
No.
Not me.
Not this year.
Exactly. You can always point to that as well, because code won't make it to production if tests fail during the CI/CD process. But again, if it's just a one-man show of kind of startup where you're also developing the logo whilst you're doing the website and the app, then it might be difficult. But so we have a developer to test a ratio of like eight developers get one QA at ClearScore, and I think that's a normal type of ratio for a medium-sized business. But in the beginning, you might find that if you have 20 developers, one QA is enough. But if you really are concerned about stability, you should at least have one QA for every 10 engineers.
Yeah. So how does the QA process work? If you wouldn't mind just telling us at ClearScore, how does that work? Because you're obviously running all these tests when you're doing a pull request or whatever. I'm imagining that's all automated, and if anything fails, it's going to fail when you do that, and the PR is going to fail. Where does QR fit into that role? Do they then go and do you do automated testing? The QAs do automated testing as well, or is it? I just want to find out about your process, your like end-to-end process. Yeah.
Oh, okay. Well, let me get those slides up. Okay. Well, in brief, work is only ready to pick up when there's when the technical specification includes some conversation around testing. So the QA would then only come to a developer once they've spoken to the product managers, product owners, the designers, and engineering managers, and developed a fully scoped out technical specification that includes previous discussions around the business case for a certain feature request, as well as technical considerations. So a lot of our QAs as well are previous engineers or have studied software engineering, or they're curious about becoming an Android developer, iOS developer, web developer. So they have some sense of an understanding of like what's going on within the system. So then they would write the success criteria, you would say, and then we'll then add as the engineer who's very close to that piece of code, you would then add further tests if you need, yeah.
Okay, thanks.
And then obviously then when you make the pull request, there's the CI/CD process that runs through GitHub Actions. All the enzyme tests run and the Cypress tests run, and you can't merge the code in if tests are failing.
Yeah.
But then obviously you might not have complete test coverage for a new feature, and that code still makes it into production, which is why the last step before code is released into production at ClearScore is you actually sit with the QA and the engineer and the product manager, and you physically test your feature in a manual test.
Right. Yeah. Yeah. Manual tests are always the last. You have to have that step as well, don't you? You can't automate
exactly
it. Yeah.
Exactly.
Thanks, Xola.
And then to dive into some technical, you've been around for a while. I see you mentioned Enzyme. What are you most excited about in the testing space? Like, I'm not sure if you've heard of Cypress Studio. That has generated a bit of a storm since Cypress 9 came out. Cypress also has component testing, which is really cool. There's V-Test that's making waves as well. What gets you amped about the testing space at the moment, or like even over the past let's say 2 years?
These are all new, shiny new technologies. And I mean, as a React developer or as a JavaScript developer, we're always chasing new fads. So I think in SA, I see test-driven development being adopted across more companies, regardless of the technology. And again, it's more about the philosophy around testing. So focusing on mental hygiene for engineers, focusing on stability and total quality management. Because again, testing begins even before the developer picks up the tickets. So I just see a general trend where we, as South-African engineers, front-end engineers, we become more and more competent. I am interested in Cypress Studio as well. And I think a recent trend has also been that we are testing for accessibility, which is very promising. So understanding how users who can't see or who are visually impaired or blind can't hear will interact with an app. So that's a very exciting trend. But in terms of the new specific technologies, I wouldn't be too fazed by the latest marketing buzz.
Okay, like I'm personally crazy about.
Sorry.
Go ahead.
I also think there's also been a company that I've worked at, a refocus on like post-release monitoring. So trying to understand which specific releases are affecting which population segments in which particular ways, and then optimizing. Because the question again isn't really like should you develop a new feature anymore. If you are using the V model, it's what's the incremental feature development that I can do that will optimize the user experience. So having solid post-release monitoring using tools like Sentry and Amplitude, and being able to segment that data and really dive in to the trends and the undercurrents in the data allows you to like do those optimizations.
Okay, awesome, thanks. Cool. I think that's everything. Yeah. Xola, thank you once again for spending your time with us and sharing your experience. It's been really insightful. And yeah, good to spread out the good gospel of testing. Spreading some good in the world.
Cool. Thanks, guys. Thanks for having me. I'll see you guys at the next talk.
Yeah, thanks very much for joining us. And yeah, keep an eye on the meetup, and we'll be advertising some new things soon. Thanks all.
Awesome. Have a good one.
Cheers.